So some more on data services, right? Base maps, although they are layers, right? That sort of thing. It's really base layers. It's a beef I have. So Google, Bing, ArcGIS, OpenStreetMap, many more. But usually you have some type of base layer to, I guess, place you in some area, right? To give you a background. Then the big thing, in all honesty, are operational layers. And these are terms I'm borrowing from the ArcGIS API. That's what they call them. But basically, it's your vector layers. And why vectors? Because vectors have attributes. And attributes, we can use those attributes to feed the pie charts, the donut charts, the radar charts. We can feed other controls, gauges, and indicators, and that. So vectors become very important that way. But then also, the big one is editing. Are we going to be doing the CRUD stuff, create, read, update, delete kind of concept on the editing? It's another sort of thing to think about, and whether your web service provides that. And a web service can be more than vectors. A lot of these web services, you can query them and they can calculate stats for you, min, maxes, averages. You just got to check out what does this service provide. And something like PG FeatureServe can do really complicated queries. You could call a custom function and have something like take some points, buffer them, intersect them with another data set, and do some group bys, and sum up some vegetation categories or something. So it all depends what you do and what these services allow you to do, and that they can get a lot of work done for you at the same time. And I think it may sound simple, but some of them can order and sort. So when you request some data, you can actually ask for it in ascending, descending order. And it may sound trivial, but are you going to write 20 to 50 lines of code, a double nested for loop to do a bubble sort on your own? Or can you knock out that code from your app because you can just, hey, ask the back end to give you the data in the order that you want, kind of concept. So there's always like things as you learn about a particular service and what it can do, how it can offload some work to what we call the back end. So that's a good segue, more on the back end, right? So the big issue is like front end apps aren't much without back end data, right? And if they're meant to be dynamic and they're meant to live for a long time, then they need to be actively pulling the latest data from production would be the concept, right? So there's always going to be trade-offs, right, in terms of what can Mapbox do, what can Google do, what can ESRI do. And the thing is, when you pick those, you are doing you may not realize you're making a trade-off, but you will be, okay? And so how do you choose a backend web service? First, you have to know your mapping client and what it supports out of the box in that. So Leaflet out of the box really likes lat longs. It really doesn't like any other projection, even WebMacator, even though the base maps are in WebMacator, right? And so it takes a lot of some effort to actually say, well, the way the data is coming at us is in UTM zone 10, so we're going to have to flip it into lat long or WebMacator on the fly, right? However, what if the backend is fixed? Like I said, Like I said, okay, it's 26910, like I said, and so we can't get lat long, right? And so then you might have to be prepared to pivot off your client. Maybe your particular client, the way it's set up, can't handle this particular data, and so you might be like, well, I love Leaflet. There's nothing wrong with that, but for this particular one, because of the way the data is set up, maybe we have to switch to open layers. So let's go over some of the basics again. Some of this, a lot of the base maps / layers are pre-rendered tiles, and they're usually image tiles, JPEG, PNG, maybe GIF. I haven't seen too much GIF. PNG is pretty popular in that there's less royalties involved, so it's in the end cheaper for someone. And that some of the base maps are coming as pre-rendered vector tiles. We'll talk about vector tiles coming up in a demo. So maybe they're not images. Okay, but you'll know if it is an image, and the labels are also part of the image. So when you do a rotate like a two-finger rotate of the map on your phone, you'll notice that the labels are kind of like stuck in the image, and the labels will rotate and be in that. You might, but however, I've been in some like Google Maps and a couple of other products that when you did rotate the map, that the labels try to stay orthogonal to the plane, and the only way you can do that is if you take the labels out, right? They can't be part of the image in that. 256 by 256 tiles are common, so common that some people are expecting it, right? 28 zoom levels are common, but some have less, right? It's that same quad tree that we went over before, centered, central meridian, equator, whole world, like we can call it, 1. You step in, you're at level 2, so now you got 4 squares. You step into level 3, you got 16 kind of concept, and it keeps breaking the tiles down that way. And so some of them are really expecting that, and not only that, but they're expecting the 3857 projection as well. So that's common. It's a common assumption, right? But what happens when you're not? Well, that's not my leveling scheme. That's not my origin, and that's not my projection, right? So this is what happens: blank map, and you screaming, "What's going on?" Right? That sort of thing. So just be aware. Sometimes in early development, maybe stick with Webmacator on your data. I actually had to flip some of my data into lat long to make it work with Leaflet because I was in this situation. Blank map, where are my dots? This should be working out. Just some places I check. The Gulf of Guinea, it's over by Africa. Sometimes they end up over there. Just a strange case, they end up by Brazil in that. I have some YouTube videos from another course that go over that. But yeah, your dots can end up in all these different places. If we're not following the assumptions of a particular mapping client, and sometimes those assumptions are not well documented. You run into them like a invisible brick wall, wondering what you just hit. Talk a little bit about tile type servers. One of the earlier ones are called Slippy Tiles. It has a strange name because in the beginning, once upon a time, like all our web services were dynamic. We would say, hey, I'm looking over here with these layers on, tell that to the server, and it would send us back one image. So there wasn't this concept of a tiled image. We get one image back. We'd pan or zoom, it'd do the same thing, we get one image back. So the Slippy Tiles is this, concept that you can pan and zoom the map, and these little chunky tiles start filling in the space that you just pan and zoom over. And so there were a lot of assumptions built in on this tiled, image tile concept. 256 by 256 pixels, that's the size of your tile. What if you tile differently? You might throw one of the web mapping clients off. The tiles were PNG files, right? And so we've seen this format. We tore this for OpenLayers. We tore this format apart. But the original Slippy tile format was zoom XY, where zoom is a directory, X is a directory, Y is the first part of the file name, .png is your extension. Okay, so this format or tiling scheme has been around a while, right? It's very directory based. When I exported some Mapbox vector tiles out, it put them into an SQLite database. You'll see this in the demo later. And so I end up with like a 4 or 5 column table where one column is Z, one column is Y, one column is X, one column is Y, and then there's a column with a blob that actually has the tile in it. So this thing of zoom XY and then a 256 by 256 tile, either in PNG, JPEG, or maybe Mapbox vector tile format, pretty common. So it should look familiar to us. Zoom is a dir, X is a dir, Y is a PNG file, right? And so X is a subdirectory of the zoom level. So there's been some extension. Again, we went over the OpenStreetMap one in detail in a previous lecture, but what did they add? They added an S, right? So they still have the Z for zoom, X, Y, X for another subdirectory, and then Y for the file. But they added S on the beginning to do load balancing, so you can have many servers serve up many tiles. Okay, MapTiler does something a little bit different. So they've got the Z, the X, and the Y. There's two things they free up: the dot format. Hey, do you want PNG? Do you want JPEG? Do you want Mapbox vector tiles? Now, but they got another thing on the front called Tiles ID. So what is that about? Okay, format we can kind of figure out, but it's a Carto option. And so what I mean by that, that's what I called it, right? But that's like, we've seen it on Google Maps where you can switch from satellite to street to topo. And so it's kind of like, if say you had like the same data themed up with different colors, but you had like, like a cool blue version of it, and there's like forest vegetation, chloropeth mapping or something. So you had the same data, but it's color ramped or classified differently, right? And so you build all the tiles, all the zoom levels, and all that, but you let a person switch out on a cartography option of how you stylize the data. Right. Format, we can kind of figure out flexibility, not just PNG, maybe JPEG, maybe we'll get fancy MVT, Mapbox vector tile. Or, should I go back? Why not? Or there's another format out there that we'll go over in a demo, protocol buffer format, which is just a binary version of JSON. Yes, what about MVT? Indeed. Mapbox vector tile. Now I've seen the V replace MBT, right? But because I deal with Postgres, the function has a V in it, so I'm going to go with that one. In that, but I have seen an MB as in Barry T versus an MV as in Victor T. So, but I'm more familiar with the MVT, meaning Mapbox vector tiles. In that. So, what is it? It is a vector version of the previous image tiling scheme. So, same size, same origin, same quad tree concept, same zoom levels, like same kind of structure that way, zoom levels. We'll call it X levels, Y files kind of concept. So everything that we were doing in the pixel land, PNGs, images, and that, but just doing it with vectors. In the end, for speed and because the slowest point of your app, if it's networked, is the network, right? That's still a problem, no matter how much bandwidth we throw at it. A bunch of people really far away from the closest cell tower, all hitting the same cell tower, trying to get data. When it's coming in text format, those can be pretty big. And so the protocol buffer format just takes something like GeoJSON or some other type of JSON format, and instead sending this big chunk of text, it just quickly encodes it in binary and sends it over. And so there's less to send over the wire. So it is your app feels much faster, less lag. Okay. So it's basically binary JSON. Now, yes, you might hear the term, it flashed for a while. I mean, everyone calls it protocol buffer format now because it's a Google spec, and OpenStreetMap used it right away. But you might run into something called BISON, binary JSON. But this is kind of what we're talking about, right? So, in that. In the end, it is JSON in there, just in binary format would be the concept. And why do we like that? Oh, another thing about Mapbox vector tiles, attributes. Usually when we send over the image, right, it's already colorized red, green, blue. There's not really any attributes on the pixels. But when we send these vectors over, you can have attributes. So if you send enough attributes, people have the chance or opportunity to change how you've styled the data. So maybe they don't like the blue dash line that you're using, and they have the ability to symbolize it differently. So it does give you that kind of flexibility. Also, if you're labeling the features based on the attributes, then when someone rotates the map, you have the ability that the label is not burned into the image, that it can float more freely as the map moves. I'll see if I can, if I can hunt something down on my phone and take a video of it. I will try to see if I can add that to the playlist for fun, so you can see exactly what it is I'm talking about in that. The one thing about Mapbox vector tiles, each tile has its own origin. So each tile has a 0, 0 in the upper left-hand corner. It's much like pixel space for an image. That's identical. And then the point furthest away is the bottom right-hand corner. And so whereas something like GeoJSON is real-world coordinates, when we're dealing with the Mapbox vector tiles, it's conceptually it's these pixel coordinates. Starting upper left 0, 0, bottom right will be the highest number in that, probably around 255 to 255 for following the spec in that. There's a thing about spin. So if I do a demo, we'll try to make sure you can see that spin happening in the specification. I think they're the good old clockwise on the exterior rings, counterclockwise on the interior rings, and that follows the spin very much like shapefiles and a few other products. Other products spin it the other way. OGC, Oracle, they do a counterclockwise spin on interior rings in that. But it does get into like nesting polygons and cutting out holes and that sort of thing. So if you had an island that had a lake that had an island on it, right, getting it to shade in properly. So what you can do now is pause this video lecture and watch demo 5 on Mapbox vector tiles. So I'm going to switch. Well, no, it's related. We'll talk about some recent, not too old, maybe might be in its second year now. Middleware, PG TileServe. So what does it do? The PG part. So it takes data in Postgres, the PostGIS extension, and magically converts it into Mapbox vector tiles. Not so much magically, because that's kind of built into the database. In that Postgres has a MVT out option, so it probably leverages the database as much as it can, in that. But it's a way of having, instead of you hitting Postgres SQL directly with your web browser, which is usually difficult, it's the middleware in between that it does REST JSON. So you talk to PG TileServe and you get your Mapbox vector tiles as your base map in the background. And that PG FeatureServe, it spits out GeoJSON, right? So not real world coordinates, GeoJSON in that. But again, what's the magic? PostGIS has a GeoJSON out, but the problem is we don't have database libraries built into browsers. Like, browsers don't know how to directly connect to Oracle or directly connect to Microsoft SQL Server, MySQL, or directly connect to, I guess, Postgres in this case. Maybe they can kind of get at MongoDB because MongoDB spits out JSON and GeoJSON because that's its sort of operating unit. So there's ways to set it up. Mongo to actually, because its native format is JSON, then there's nothing that really needs to be converted. It can be injected right into a browser in that. The great thing about PG FeatureServe is, you notice it's not Mapbox vector tiles and that sort of thing. So basically, it's almost like you can do like a can query in the database or do a query, not so much select star from kind of concept, but pretty close. You can set that up in the database and expose custom functions and views and stuff so that a query is actually happening back in the database, and we could even inject some geoprocessing in there and send the results back as GeoJSON, right? They're both REST JSON services in that, built in Go, so they're meant to have a low footprint and fast. They don't really maintain any kind of state information in that. So they are stateless because the state is the data back in the database. It's just all it does is trims it all down, right? It's not trying to do what GeoServer does, because GeoServer converts all these different formats. It's just focused on PG. It's leveraging existing function in the database, and it's just about having a little piece of middleware that just quickly converts the data in the Postgres database into a format that the browser can easily ingest, and the browser can easily do GeoJSON. Now, the Mapbox vector tiles isn't directed directly at the browser. It's directed at the mapping clients. Most mapping clients, Leaflet, OpenLayers, ArcGIS, JavaScript API, can handle Mapbox vector tiles. So if MVT is coming at those clients, they can easily map it up and get it onto the map. And so that's their game. So MVT is real about targeting the mapping clients. GeoJSON is targeting maybe the layer level or the data level. Like maybe that GeoJSON is not going to the map at all. Maybe we're going to use those attributes to populate a chart. So what about Google Maps? Right, it's still out there. It's not a full GS, but let's not foo-foo it or brush it off. It's got some nice functionality to it. It does have some geocoding. We use it all the time. It has a little bit of enrichment. It can do directions. It can do a little bit of measuring off the map. It can do give you back spot elevations and that sort of thing. So it's got some interesting stuff that could help out some people, right? Base maps are popular. But you usually need an API key to build an app, so it's not 100% open. There is some things you got to do. They do have libraries for JS and PHP for working with these backend services about geocoding and enrichment and directions and that. So you got some basic functionality that might actually be useful to your particular application. Okay, and the thing is, I'm going to go, what about KML? Because we're talking Google Maps, but then some people are like making this assumption. Well, yeah, I want to, I have all these KML files that I want to drop on top of the map, right? And so KML is like a separate thing from the base map. It is a XML language. It looks very much like something called GML. They're really close. KML's keyhole markup language. GML's geographic markup language. They're really close. The element names are really, really close to each other in that. And so it's a good question. What about KML? Because because we've been talking JSON and GeoJSON as being the rulers of the domain, but KML is still kicking. And as soon as I thought it was fading out, this year in App Studio runtime 100.13, pretty recent in the runtime side over there, they dropped in a whole bunch of KML stuff. And a whole bunch of stuff around editing KML files on your phone and tablet. And I'm like, well, I wasn't expecting that. If I was honest, I was like, okay, I thought it was fading out, but all of a sudden, boom, there's all these new libraries. So they obviously have a big client who has a lot of ESRI licensing who says, we need this in the runtime because we need to edit KML files in the field. And so maybe it's the U.S. Geological Survey, maybe it's the Department of Defense, I don't know. But it's obviously one of their bigger clients because they wouldn't add all of this. We've been rolling on the 100 version of the runtime for a while. And so to have all this show up, in 2022 is kind of interesting. And so it's funny, as soon as you think a technology is dead, there it is, just still alive and kicking, and that sort of thing. Because it is a text format, it's XML, it's not JSON, but there's enough libraries out there that can flip it. Lots of mapping client libraries can bring in KML files directly and display them on top of the map. Right, but I would say check your web mapping client. Right, get in there into their help docs, do a quick search. If you have to solve a KML problem over the web, make sure you have a client that can easily bring it in. Right, you don't want to be burning a bunch of time parsing it yourself, or doing some KML to GeoJSON conversion on the fly. See if they've got a built-in layer ready to go that can handle it.